start. Yeah, well, good evening. Yeah, so I'm going to do a talk on digital forensic imaging and analysis. So we're going to go through a practical example that I downloaded from NIST. So the links are in the PDFs, in the presentation. So when you get the presentation, if you want to download the files, the imaging files, you can do that and play around and see what you can see. It's a pretty good example because it has to do with data leakage. So someone in the scenario will go up before we get into it. But someone actually stole some of the company's documents, and it's basically to just go through the analysis to see what and how they went about it. Okay, so I'd like this to be interactive, so if you can contribute, please do. If you have a question, please ask. If I don't know the answer, I'm sure somebody will answer it. I only got the image on this weekend, so the analysis is going to be as interesting for you as it is for me. I just pulled it in. So we're going to check some stuff. We'll see how far we can get through it. We won't be able to get through the whole thing. But as I say, the link to all those files will be in the presentation. So you can download the answers and everything to see exactly what type of artifacts was pulled out of the image and how they actually went about compiling the report, which then obviously could be used in a criminal case or in a HR disciplinary or whichever way the company would decide to go. Not everything ends up in court. Right? Okay, so the agenda, we're just going to, for those of you who weren't here in July, we'll just go through a quick recap of what is forensic. Don't want to spend too much time on that. Sources for digital evidence, disk image sources, disk images, creating an image. Did anybody bring a flash drive? You bring it? Bring it? Okay, so if we've got time, we're going to just make an image of it. We'll pull it into Balkasoft, and we'll see what we can see on the drive. See if there's any deleted files, see if anything can be carved off the image. Okay, and then image file formats, different types to get. Creating an image, dead versus live imaging. And then accessing forensic image for analysis, and I'm going to go through the practical example, and then look at the flash drive. I've got Raptor, which is, well, it used to be freeware. It's still available if you can find a copy somewhere on the web. It's an ISO image, you put it onto a flash drive, and then you basically make yourself a very cheap man's write blocker to make images. But I'll explain that when it will make sense when I explain what a write block is used for and why we're taking images. Okay, so as I said, the main source, the evidence comes from NIST. There's the link. Everything's there, so you can go download. It's about 5 gigs. And then the SANS Forensic Imaging. This is the document that was released in 2015. A lot of the slides, the information on the slides come from that. It's a very good source. It was actually written for people getting into forensics and forensic imaging in particular. Okay. So what is forensics? So forensics it means for the court. So it's based on Latin forensis. So and forensics obviously can be any type of forensics. It can be ballistics, it can be DNA, it can be fingerprinting, digital forensics. There's a whole host of different types of sciences, forensic sciences. Okay, and evidence should be done in following principles of science. The science, I'd just like to point out, is Western science. Okay, so I was going to do African science. I was trying to decolonize computer forensics, but then I realized I had an image of Ubuntu that I could do nothing with. There's no hardware to install it on or anything, so too soon?
Too soon. Forensics was full.
Okay, so computer-based electronic evidence. It's latent evidence. So it could be intact, it could be partial evidence. You're basically looking for any wrongdoing, whether it's cyberbullying, cybercrime, fraud, copyright infringements, etc. So computer-based evidence is fragile, and it means it can be altered, damaged, or even destroyed due to improper handling. So this is essentially where this talk in particular comes in. It is about dealing with imaging and doing it correctly. Okay, so this was the all-encompassing thing that Casey came up with. You and Casey, smart Irish dude that lives in America now. Okay, so it's digital evidence is defined as any data that can establish that a crime has been committed or can provide a link between a crime and its victim or a crime and its perpetrator. Sources of digital evidence: personal computers, mobile, smartphones, telephone records, transaction logs, emails, access control logs, internet activity logs, antivirus logs, digital photographs, geotagging with or without, social media applications, GPS, digital storage, host of those, printers, and RAM. Okay, so scientific method basically just to say that it should be reproducible. When you present evidence, it should be, firstly it should be true, and anybody should come to the same conclusion. Anybody with experience should come to exactly the same conclusion. Presenting evidence, you're not presenting your opinion. As far as you're concerned, you could care less whether the person is innocent or guilty. You're just presenting the facts from the evidence that you analyze. Okay, so these are the common steps, because that was a brief cap. Any questions at this point? Anyone? No? Okay, carry on. Okay, so there's generally 5 steps to a digital investigation. You've got preparing, so that would be making sure that whatever you need to go off and do the triage. So everything you require, computers, software, hard drives to do the imaging on, flash drives to do the imaging, all of that stuff, how are you going to go about doing it? That's over there. Then you've got the survey and identification. So this identification is essentially your trigger. What triggers you to go and do it? Is it a phone call? Is it a police case? What triggers you to actually go off to go and do the analysis? Each lab generally have their own procedures to do and how they go about tackling it. Essentially, all of these things are required to have a chain of custody or chain of evidence, to make sure that you say that what you collected here and what you've analyzed in these steps and represented here or presented in the report is what you're saying it is, and that obviously it has not been altered in any of these steps. This talk is just going to focus on these 2 steps, which is the preservation, collection, acquisition, which is through an image, and then an examination and analysis. Okay, any questions? It's very quiet. Everybody got a drink? You haven't got a drink. Well, do you want a question? You want to come smack? Okay. So image sources. So where do you get to? Where can you get images from? From a disk, there's two. A disk consists of two parts. You've got your physical disk, and then you've got your logical volumes. There's an image in the next slide, so you'll be able to see the difference between a logical volume and a physical disk. Why this is important: you can make an image of a physical disk, or you can make an image just of a logical volume, or a number of logical volumes, or files or folders. Okay, so you don't have to make an image of the entire computer. If you're only looking for a certain thing, especially in a network environment or in a live environment, like in a banking system, you can't shut down the bank, or you can't shut down the servers to make an image. You'll pull the relevant logs off, you'll actually make a copy of it, you'll do a hash code of it, and then so that anybody else that would have to analyze the same evidence should come to the same conclusion, because you don't want the evidence to change where possible. if you are in a situation where you are capturing live evidence, then you need to be able to explain why it's relevant and how it has not been changed. Okay, so we'll get to that. Okay, and then the challenges with solid-state devices. Okay, so the issue with solid-state devices when compared to your traditional mechanical drives is how data gets written to the solid-state device. It's not the same as a physical mechanical drive that has sectors and tracks. Whereas on a mechanical drive, if a sector gets overwritten, because it could be consecutive sectors, so you could actually carve some data off. So you can get a partial image, you can get, say, a partial file, you can get a partial file that's in the printer spool. But I mean, if it shows intent, or it shows exactly if it's a copy of a threatening letter, and and you can say this can be linked, then I mean that's what you need to do, right? Okay. Yeah. So the logical volume. So on this disk, this is the physical disk. So it could even be a solid-state device. You've got your MBR, which is your master boot record. Then you've got, in this instance, you've got two logical volumes. You've got your C drive and you've got your D drive. So if you were doing a physical disk image, then you'll be imaging the whole thing. Master boot record, C drive, and the D drive. And if you're doing a logical volume, you would just be making volume up of the C drive or the D drive or both. Okay. Questions? Okay, so, sorry? Sure, you can ask. Have I lost anyone? Yes, go for it.
I do have a question there. I'm not sure whether, I don't have an answer myself, I'm not sure what you do, but when dealing with things like radar arrays or SANs, have you dealt with, have you looked at taking images? Because obviously, depending on the radar array, it could be proprietary software there to deal with it. It obviously gets a little more difficult because your volumes are bigger. There's hardware involved, possibly, to manage it. And then obviously things like the sounds.
Yeah, look, I mean, even the sheer volume is a concern, right? So I think you need to look at what, I've never dealt with it. But you need to look at what is your goal? What are you trying to investigate? If you're investigating somebody adding users or conducting fraudulent transactions against the database, then that is what you're going to be pulling. Obviously, it doesn't make complete. I mean, it won't make sense. But as long as the thing is, the main thing is you need to be able to explain the evidence that you've collected. Because obviously, you don't want to be sitting with an 80 gigabyte database if you're only interested in a couple of the records. So yeah, and it's the same with, and also in a lot of instances you can't take the database offline to make a forensically sound image. So whatever you do, if you decided to take the whole database, then you need to have to explain why it's relevant.
Yeah, I mean, I suspect specific volumes.
Yeah, it's unlikely. I mean, if you look at a case like Enron, then obviously all their servers are going to be seized. But then someone like the FBI does have the capacity to deal with it. Which for them, it's not really about cost. I mean, it's they have access to all the physical hardware. Is that right? Any other questions? Anybody else have an answer? Contribute.
Well, I think you've summed it up correctly. I mean, for example, on a database server or a large RAID array, large application server, whatever, and you think there's evidence on there of fraud, like it's not going to be that somebody will delete the files. Typically, if it's a database server, and they might try and delete the records from within the database, but looking at the file system or physical disk is not going to help you recover anything. Somebody's deleted files, I suppose, yeah, but you can't do that on a database system. Maybe log files.
Well, I mean, if you look at internet banking fraud, I mean, you from a banking perspective, all they're going to say is whether the transaction took place. In most cases, it's going to be yes, it took place. But I mean, as far more than that, they're not going to give more information out unless they're subpoenaed. Right? Okay, anything else? Yep.
And you spoke about live evidence.
Yeah, I'll get to live and dead.
And,
So that sounds
and then
good.
the main difference between a solid state drive, why is it so much more difficult?
It's the way that data gets written on solid state drive. So, the chances of data being overwritten on solid state drive is a lot greater because it's written consecutively or sequentially.
Oh.
Yep.
There's that, and
It's not fragmented like you would have on a mechanical.
well, there's that, and the drives do wear leveling, so they'll repackage blocks and things like that, and they'll actually rewrite, and after you've deleted something, they'll be like, oh, you don't need that anymore on a solid state drive, so we'll take those blocks that have been deleted, and we'll ignore them, we'll take all the blocks that have not been deleted, and we'll go and make a little space, and we'll copy all the blocks that have been, for files that are still exist, put them in the new area, and then wipe out the old areas. So the drive is busy deleting data.
Yeah,
And
that's exactly it. The erase cycles
yeah,
and wear leveling.
trim, etc.
Yeah, exactly. Did you have something, Christy?
So, in terms of we talked of custody of evidence, with the police or state prosecutor keep an image of a disk somewhere on a server or an evidence room until the case goes to court, or do you make a report of what you found? That
Oh, well, yeah, okay, I understand what you're, okay, so what you're asking, I understand what you're asking. So it depends on what, firstly, where the evidence lies depends on what type of case it is.
yeah.
If it's a civil case, then the evidence normally seized is seized through an Anton pillar, and then that evidence actually goes to the sheriff of the court. In a police case, if it's obviously a criminal offence, something like child porn, then the police obviously keep the images of it because it's illegal to have any copy of child porn. Even if you're a forensic investigator, you just can't explain that away unless you have been tasked by the state to analyse the evidence. But then it's also quite a lengthy process to get permission to be in possession of child porn. It's a criminal offence to have child porn. So to answer your question, it will actually evidence that's seized in a criminal case will stay with the police until it either gets processed or it will stay with specialised units like the Hawks or with the SIU, Special Investigations Unit. Usually they keep the physical drive and the image. In a civil case, you'd make an image. You'd obviously, when the Anton pillar is served, you'd make your images and whatever, and then the images and the original goes with the sheriff of the court, and it will be kept by the sheriff. You won't even start analysing it because the person who had the Anton pillar served on it, they can contest it, either to the legality of it or whatever. And only once that has been finalised, then the evidence will go back to a forensic investigator, and then they'll do the analysis.
So when you say original, do you mean the physical disk?
It should usually be the physical
So when you talked about, like, for instance, a bank earlier, you can't just necessarily pull physical disks out of a bank, right?
No, you can't. The thing is, you would have to, the bank needs to play ball. And I think that's the whole thing. That's what's being in the press at the moment. The banks are basically telling the ombudsman that the user lost their credentials, and the ombudsman saying, oh, okay. And then they basically push it back onto the customer of the bank who lost the money. So yeah, it's difficult. But there's going to be a lot more light on, especially with SIM swapping and internet fraud, banking fraud, in the press in the coming weeks. So check out the Huisgenoot and the EU.
Like, RAID is somewhat awkward. If you think about it, in some kinds of RAID, you can just pull out the disk and replace it, and that would be your evidence. In other levels of RAID, it's across 5 disks or more. So it's an awkward.
Yeah, you need to know your stuff to go and pull out a disk. But there again, what are you investigating? You may not need all the evidence. You may just need a file. Exactly.
So, yeah, I'm just asking because it seems like taking the whole disk is an old school way of doing it.
Look, in a civil case, it's the thing is, if I'm accused, or if anybody's accused of child porn, you're not going to give them the porn back, right?
Yeah.
So it probably depends on the offence, but that stuff usually goes with the police. Look, I've got the evidence, so they can give you the stuff back. So you can, for argument's sake, if you go to court for your bailing, you can tell the judge, I need my computer, I use it for work, and they've made images. There's absolutely no reason. And if the judge, if you can make a case to the judge, they'll have to release that.
I think the one scenario that changes it is if somebody has tried to hide the evidence already. So if somebody's gone and deleted logs or files, versus when you're going to a party that is keeping logs and files, and you are trying to obtain a copy of it in order to analyze. In the one case, you're going to have to go and process disk images and look for evidence of a file that was there. And you don't know where on the disk it is. You don't have management layer tools like redo logs or like a file system to say, well, this is the start and end of the file, and you can have a copy of it because the file's been deleted.
Yeah, for sure, but you must understand that once you seize the evidence, you don't know what you're seizing. You can't prove that somebody was trying to hide it until you analyze it. So, and you'll see I'll show you in the example. It might actually make a bit more sense. But you can suspect someone has done something, but I mean, if you don't have proof, I mean, it means nothing. So, I mean, it goes back to yeah. You know, what was the identification? Money's gone on my account. Okay, so what do we need to collect? And you go off and you go and collect. So I mean, you don't know. I mean, somebody could have stolen money. They could have tried to cover it up. But at this point, even at this point, you don't know. You only find out that someone was trying to. And this is what obviously helps the prosecutor is that if you can show intent, somebody's trying to cover it up. They know they've done something wrong. I mean, that's something you can't explain away.
I still think that the distinction lies in if you know that the criminal is outside of the bank, then you can basically depend on the bank to give you their records with sufficient motivation to the bank.
Yeah.
However, if the criminal is inside of the bank, then you need an image of the file system or volume. If the criminal is outside of the bank, then you can probably ask the bank for log files which are still present on the server.
Yeah, look, I mean, every system's set up differently. Every company has their own backup schedules, their own retention schedules. So obviously with a financial institution, the retention schedules are a lot longer. Cell phone companies, their call logs, itemized bulletin, their retention's also a lot longer. So yeah, I think you need to be, sometimes you have to be creative. And, you know, that doesn't always work, but, you know, you try and apply the best scientific principles that's available to you at the time. So it's, you know, the law enforcement also sometimes do some questionable things to get what they want, right? If you look at how they hack cell phone networks and put up dummy cells, that's done quite a lot in Europe. You know, it wouldn't be done here. So yeah, okay. So we'll carry on. I know we could discuss this for ages. Yeah. Sorry.
I just wanted to ask, from a legal perspective, how do you validate the image that you've taken and bring it to court?
Sure.
So that they don't discredit it. Is that through the scientific methodology that you use?
No, actually, it's very simple. You use hashing. So you do MD5, SHA-1, SHA-256, whatever you want. But the thing is, you make that usually gets done as part of the imaging. You take the hash code, and then if anybody else takes an image and they do the hash code, they should get exactly the same thing. So that they will show that. I mean, if you change one bit on that image, the hash code is going to change. And if that's the case, you're going to have some explaining to do to say that what you've pulled or what evidence you're presenting is actually what it is.
And the people that are involved, like the lawyers and those kind of people and the judges, I mean, do they have a relative understanding of how this stuff works?
No.
No,
they're legal people.
The experts
That's and that's the thing. I mean, it's a problem throughout the world, right? Is that it's still, people still have to get used to it and believe what it is. I mean, it's the same as DNA. I mean, people dismissed it initially, and it took a while. But I mean, now it's commonplace in the court of law to use DNA to say that person and only that person, with the error rate of 1 billion or whatever, was there. So it is obviously, it's South Africa's, I think it's easy in the sense that you're actually only presenting evidence to a judge and not a jury. But yeah, it's a double-edged sword, forensics at the moment. Even in America, if you look at what happened in the Casey Anthony case.
Just would like to add something for hashing. The best method for hashing the image is to hash the files, then hash the folders with all its contents, then hash the full disk itself. So you maintain the integrity of everything in that disk image itself.
You can do that, but if you've got an image, and you hash the image, that's all you need. When you pull it, when you run the report, and I'll show you just now, when you run the report, you can pull the hashes out as well. So that if anybody pulls it into whatever tool they want, they don't have to use this tool, they can use any forensic tool, the hash code should come back the same. So it's a very long-winded thing. If you've got 30 machines, that's not really what you want to do.
Yeah, but like that's for keeping sure that you are exactly hashing everything in every file, and nothing will be altered, even the file itself, or the folders, or the hierarchy of the file.
I was just saying, leading up to the hashing of the file image is also a certain procedure to follow, creating that image with the right block, etc. I don't know if you're going to cover that later or.
Yeah, well, we're going to get to the right block now.
Yeah,
so.
and also chain of custody, about that computer is seized or which the drive comes out of before, it's normal preservation of evidence kind of.
Exactly, all that stuff goes into your report. How did you get hold of the evidence? I went to this site. I was contacted by the police. I went to the site. I took an image. How did I do the image? I did the image with Raptor. I did the image with FTK Imager. How did I create the image? These are the hash codes for this image. So that anybody else who takes that evidence can go around and say, oh, is this the correct hash code? Then when you pull the evidence out, files or images or videos or whatever, you can put those hash codes in as well. You put the offset of where it is on the image, so that it's a pretty comprehensive report. I'll put up the report for this example to show you what type of information. It's very detailed. Okay.
So just to add, I think we're capturing this evidence like any evidence. You have to have procedures. It has to be a competent person, shown to be, know what they're doing in capturing any kind of evidence, including this. So they have to be familiar with the tools. The tools that they use to capture the evidence have to be proven to work. And then again, as you say, hashing it. And then once you've got that image, then that can be given to investigators. You never touch the original. So it's
exactly
for any evidence capture.
Yeah, I've got that up on a slide. So, but you're absolutely correct.
Yeah.
You use scientific principles. It's proven. Okay, so let's carry on. Okay, so forensic images that can be compressed. Embedded disk images are disk images that contain metadata about an image, such as creation times and cryptographic hashes that act as a fingerprint of the image. Okay, so the difference between image and cloning. So image is a forensic copy. It's a bit-by-bit copy. So if there's a 1 on the original, it goes and puts a 1 on the image, and that's how it goes to the whole drive. So it's an identical copy of the drive. Whereas cloning, it's also a bit-by-bit copy. But a clone is actually if you want to replace a drive. So it's not really for forensic purposes, although you can use a clone drive to do a forensic analysis. At the end of the day, you need to be able to explain why you're analyzing a clone. And this comes, you'll understand when we get to the live versus dead forensics. You need to explain why you're using this method. If this is not based on current scientific principles, then you're going to have to explain it pretty well. Because if an expert comes in and says that's not the way to do it, then then basically all your evidence is out the door, right? Okay, and yeah, but the clone obviously needs to be mounted as read-only because just booting a machine actually changes files in the system, creates events in the event logs. So that's obviously not forensically sound, right? So you don't want to be booting a suspect machine up before you make an image. And if you do, you need to say why you did it. Okay, so this is an example of a clone. So you take your source disk. This is essentially, if I don't know if anybody's replaced a mechanical drive in their computer with a solid state drive, and you've made a clone of the disk because you want to keep your life. You want your system to be exactly the same way that it was with the mechanical drive. Then you do something like this. You do a clone, and then physically replace the hard drives, boot up with the solid state drive, and then you're good to go, right? Passwords, everything. Search history, everything's in. And then an image is you taking either the entire physical disk, or you're taking a logical volume, and you're just creating an image on a destination disk. This destination disk doesn't have to be a physical disk. It can be a network drive, it can be in the cloud, it can be on a flash drive, whatever. It just has to be big enough to contain the image. It also does not have to have other logical partitions on it. It can just be a normal external hard drive, but you've got your videos on and all that stuff, and your music and your porn or whatever. You just dump an image on it. Okay, so that's the difference between a clone and an image. Okay, so image file formats, raw images, DD, raw.img. We've actually, the example has got raw images in addition to your expert witness format, your E01. So there's different formats you can mix and match. The files itself, E01, it actually compresses it. It's just that irrespective of which format you use, anybody else that does a hash on it is going to come to exactly the same value. And if they don't, you need to understand why, and you have to have a good explanation of why it's not the same. Your computer wasn't feeling well, didn't have its cup of coffee, is not a good answer. Okay, and then we've got EX01. Okay, so here we come to the live versus dead. Okay, so what's the difference between live versus dead? Anyway, what's the difference between, it's like living, right? Are you alive? Yeah, you can breathe and whatever. If you're dead, you can't do anything. Right, you're just a corpse. So dead imaging, that's the most forensically sound type of imaging. So the system's down. It's not in a write mode. It's in a read-only mode. It's down. You boot it up. With the imaging software, you take an image of the system from it not being in an operational state, i.e. dead. Live imaging. Why would we need live imaging? Exactly, I think what we discussed is. So in some instances, you cannot take it down. You can't tell Google, please take down Gmail so I can make an image of this guy's mail account. I mean, they're going to laugh at you. If you ask them for the stuff, they'll give it to you. Just give them the corridor. But why? Anybody have any ideas why you do stuff like live imaging? Any ideas?
Memory dump, RAM dump.
Sorry?
RAM dump, like dumping the.
RAM dump. Why would we have to do a RAM dump?
Yeah, something running, a machine running with forensic issue, and you need to make sure that you are capturing everything, that address and what's actually running in the memory.
Do you have any examples?
I think if you are trying to capture like cryptographic keys from memory.
Exactly. If the hard drive is encrypted, that's a perfect way to do it. You don't have to worry about the encrypted disk, encrypted keys on boot up. Another good idea, exactly what he's saying, RAM. Why would you want to take RAM? Something like malware runs in RAM. One thing you need to know, live imaging, if you're running any imaging software, you're going to be changing the memory, but you have to explain why that is. Well, obviously, if you start a program to take RAM down, it's going to be changing contents of the RAM. The machine's also still running, right?
You're right into the RAM, actually. I mean, like
exactly, but the thing is, you want to capture that information. Then you would use another tool like volatility to analyze the RAM dump, or you can use Microsoft to analyze the RAM dump. The memory keyloggers run in RAM. So there's, in some instances, you have to take a live image. Taking the machine down and making a dead image is pointless. The RAM does not reside on the hard drive, so making an image of the hard drive is not really going to get you what you want. So very clear. Does that answer your question? No, you had the live versus dead. You had the live. Does that answer your question? Any other questions? Follow-up questions? Okay, cool. So best practices. I think this is where it comes into what you were saying. you use tested tools and techniques. You're not going to use an application you use once and say, oh, this is definitely giving me the right stuff. You'd use tools that are used by a lot of people. Microsoft's used by FBI, so you're pretty sure they've done a bit more testing than just running one image through it. Okay. Check for disk encryption prior to powering off the machine. That's probably a good idea, because making an image of encrypted disk, if you don't have the encryption key, you're pretty screwed. Yes.
Does that mean you have access to the system itself when you?
You would have access. I mean, but I mean, it comes back to live. I mean, you do live imaging for something like that, but if you're knocking Dave out of his seat when he comes back from his coffee break or his smoke break, he's going to realize something's up, because you obviously don't want them to destroy it. But if it's a case at an office or something, the IT department will know that the disks are, that's their policy, right? So they'll know that the machine must not be shut down. Okay, IT may be a stupid question, they'll obviously have override keys and stuff like that, but maybe in a HR case, you would check.
I think the disk encryption here, it's, if your machine is up and running and the disk is encrypted, so you would be able to take an image from the actual data in the disk, because it's not encrypted at that point.
Exactly.
However, if you unplug the disk, if you remove the disk or unplug or remove the power, the disk will become in encrypted state. So at this point, you'll not be.
The person given access to this drive, to this machine, like I'm assuming, what I'm asking is, do they then give me access to the machine in the unencrypted state? Because
it depends. Look, in the UK, you have to. If you don't give the police your password, you go to jail for 2 years. So I suppose it depends on what you've done. Are you willing to sit in jail for 2 years, or do you want to go sit in jail for 25 years for murder? I'll go sit in jail for 2 years. Hopefully nobody figures out how to break encryption in those 2 years, because otherwise you're going to be sitting in jail for 2 years.
I know this is slightly off topic, but in that case, if you deny your password to the police in the UK, after that 2 years, they can just ask you again and imprison you for another 2 years.
Well, I'm not sure what the law is. I know they're also trying to bring in the stuff, especially with silent willing and stuff like that. They want to make it compulsory. So
that's interesting.
It's also CTF over here.
Oh, really?
Yeah. I think it is 5 years and 2 more or something like that.
Okay, so that is how different countries are working around it. Right? They're just locking you up. Yeah.
Assume guilty.
what's if you just outright, like say for example, if you claim you forgot your password, do they then just outright send you to prison or to jail for that? Because like,
did you shoot your girlfriend through a bathroom door? Because you still got found guilty of murder, right? He didn't go to jail because he didn't want to give his password for his Apple iPhone, but he still went to jail. So, yeah, I mean, if you're just looking at like a cyber crime, digital evidence is the only evidence you've got, then you're pretty screwed. But yeah, I think I forgot my password.
Because the thing is, like, say for example, if you are trying to be like not have the same password for multiple services, I mean, there is a chance if you're not using some services you have with passwords that you might actually forget. And say for example, if you're a person that don't restart your machine often, there might be like a character you miss. So like, what if you actually,
I think save these arguments for the courtroom.
Yeah.
It depends. Save these arguments for the courtroom. It depends who's got the better lawyer and what the judge wants to decide in favor.
Well, if you want to be a guinea pig, we can try it. I'll accuse you of child porn, and you can just and we'll see what happens to you in jail. We'll also see how the legal system deals with something like that.
We're also forgetting rather how cryptography will read the password out of someone.
I think that's the older part and the Gestapo. Anyways, let's carry on, otherwise we're going to get out of time. Okay, so encrypting forensic images for confidentiality. Okay, so image creating tools. This is a nice thing. It shows you which types of tools. These are actually explained in documents, and then where they can be used. FTK images for free. Actually, all of these things are free. The document was written about using free imaging tools. So all these things are free. As you've got DD, good old back to 1970 Unix. Okay, so accessing forensic images for analysis. Yeah, okay, so there's quite a few of stuff. You can, some instances you would use Windows Explorer, mount the image, you can just browse the thing. If you're looking for files, that might be the easier way of going about it. It depends on what you're looking for. You don't have to like analyze the entire image. Okay, so yeah, some of the reasons you would like to analyze the image directly: performing keyword searches, unallocated space, extract deleted files from fragments. Okay, so this is the image from FTK Imager. These little red crosses, I don't know if you can see them. This shows that these, it's actually read from the master file table. So you can see these files were on the drive and they've been deleted. So you can actually use FTK Imager to recover these drives. It will recover what it can. If it can't recover, it won't recover it. So, okay, so just to go through quickly what file carving is. File carving is used a lot on the mechanical drives where it uses file slack and other fragments to try and recreate the file. But if you notice that when you see the car file, you'll see that the metadata sometimes gets lost, almost always gets lost. So this is the original file, and this is what the car file looks like. So if this was an incriminating image, I wasn't at the Eiffel Tower, there's a picture of you, your head there with the Eiffel Tower in the background, you've got some explaining to do. Because I mean, that puts you there. Or if you sent a message to your girlfriend, I'm going to kill you, so I didn't send that message, and it's written there, I'm going to, same text, you're going to have some explaining to do, right? So, yeah, so that's the difference between an original and a carved file. The percentage of what gets carved determines on what's been overwritten. Sometimes you can recover 75% of it, sometimes you can recover all of it. Okay, so this is an example. You can see, yeah, there we go. So this is the original file. You can see there's the metadata, date created, date modified. Whereas on the carved file, date created, date modified is missing. Right. Okay, practical example. So what this guy did, essentially, he stole stuff from his company. Okay, so, and he was chatting, the guy's name is Mr. Informant. He was in cahoots with Spy Conspirator, and this man decided that the offer's too good to pass up. He's going to give Spy Conspirator what he wants. He's going to leak company documents. Okay, at security checkpoints, the devices were checked, and they didn't see any evidence of leakage, but then they sent it to the forensic laboratory for further analysis. So that's what we're going to go through now. Yeah, sorry, what did you miss? Okay, what part did you miss?
No, it's fine. Just from now on, it's fine.
Well, thanks for that. Okay, so essentially, we're going to now look at this evidence. We're going to look at the machine, the USB stick, and the CD, which has already been pulled into the software. And we're going to see, and this is my disclaimer, hopefully this thing doesn't crash. Unfortunately, trial versions of software are not the greatest. Oh. We'll get to the imaging just now. Okay, cool. So, everybody with us still? No one's falling asleep. Okay. Okay. That's not working. Let's do this. Okay, so this is Balkasoft. So what you'd do is you'd pull the images in, and then you'd give it, you'd tell it what you want to do with it, with images, whether you want it to carve, if you only want to get selected information, if you have no interest in pulling like your browser history, then you can untick that. You can do what they call as a known file filter. So you can actually you can analyze the image by excluding like all your Windows DLL files. What's nice about that is if somebody's hidden files in the Windows DLL files, it's going to flag them as being inconsistent with the known hash codes. So child pornographers, guys that are into child porn, they usually hide files in DLL files, use steganography. So you need to be aware of all this stuff when you're looking for evidence. Not just mob bosses, they also hide Excel spreadsheets and images and stuff like that. So the known file filter is pretty cool in that thing. A lot of the forensic software also would make sure that the extension matches up to the type of file. So if you've got a Word document that has, say, a .pdf extension, it will flag it as inconsistent. Yeah. So cool. Let's look at some stuff. So, okay. So we're going to just go through some stuff. We'll see what we can get through. It might take a while. Okay. So. From here, so all the evidence has been pulled into one case. You can pull them into separate cases. You can pull them. You can do loads of different stuff with the analysis tool. It depends on what you want to achieve. But in this instance, you're going to be pulling in the hard drive from the computer. It's volume right there. Can you hear it?
What is this tool you're using?
This is Belkasoft. It's Belkasoft. No, Belkasoft.
Belkasoft.
I'll tell you.
Okay, soft.
Yeah.
Okay, sorry. Thank you.
Okay, so there's the hard drive with 2 volumes, and then with 2 logical volumes, and then you've got a flash drive. That I like. This is the CD-ROM, and then you've got a flash drive. There's no volume on the CD-ROM. As I said earlier, the type of imaging can be mixed and matched. So like the CD-ROM is a DD image, and the flash drive is using Encase imaging tool, which is your eyewitness format. Okay, so let's look at some stuff. Okay, so So here's this is an overview. So you can see it just breaks it up into your main categories. So you can look at your males. There's 15 males. It's in brackets. These are the males that actually show the correspondence between spy conspirator and Mr. Informer. And then registry artifacts. A lot of information comes out of the registry artifacts. The serial numbers of the USB drives used, loads of stuff. When it was connected. So there's a host of information here. Okay, so let's just look at some stuff. We're not going to get through all of this stuff, so I'll just go. I think it's interesting. But all the information that you pull out goes into your final report. So going to looking at what type of Windows has been installed. Anybody know how to do that? So you can see its informant is the user for that. We want to look at the software. Right over here. Can everybody see this?
Font's a little small, eh?
You're welcome to move forward if you want to see.
Hang on, let's see if we can increase the font.
Also, if anyone's thirsty, go get another drink.
Does it
Back
matter?
informal meetups.
Yeah, is that better?
Yeah.
Is that better? Can everyone see? Jaco, can you see in the back the cheap seats?
No, it's really,
This is a small image, so it's a 20 gig image. So I think this took about an hour to pull in. It depends on the forensic tool as well. It also depends on what you want. If you want to carve data, then it's going to take a lot longer. But if you have no interest in carving the data, then you just skip it. So this one took about an hour. But, yeah, it depends on the size of the image as you know. Huh? Good. Okay, so we're going to see.
Are you checking the Windows version from the registry?
Yeah. All the stuff goes into your, depending on what you're looking at. I mean, all the stuff goes into your report. Especially with something like this, where somebody's trying to delete what they've done, and that obviously shows intent, and they knew what they were doing.
So how would you put it in your report? And detailed screenshots as possible, or do you try copy paste some of the actual?
Well, you can either you can put screenshots in, depending on the type of evidence, like images or files or that. You put in the offset where it is on the image. You can either do screenshots from here. You can select what you want to put in, and then there's also a report bookmark. You can bookmark it, and then you export the report. It will put it in this software's reporting tool, and then you can just go copy and paste whatever images you want with hashes and whatever.
So then you ever use a report in the program?
No. It depends. It depends on the type of report. You can just do a report. If you did, okay, let's just go. Let's see if we can. You could do like an HTML export. Then it will actually create the things. But your PDF is just going to put your images and hashes and offsets and all that stuff.
Yeah, it's like some of the painters software, like it's better actually to use HTML or whatever, because the PDF generators sometimes mess up some of the characters.
Yeah, for sure. Okay, so we can see here that it's Windows 7 Ultimate that's installed. This value over here is an install date. This is the date from the 1st of January 1970. So just to show you what this equates to, this is the timestamp. The timestamp shows that it was installed on the 22nd of March 2015, and that's the date of GMT. Okay. Yo.
So this is the image that you.
This is the software image. So they took the hard drive, they created the image.
Okay, so the image already created.
Yes, this is image created. Whoever's got flash drives, we can do an image quickly. It doesn't take that long. It took about 5 minutes for a 32 gig this afternoon. So yeah, sorry we're running out of time. So I thought, I can do the image. We can maybe do the image just now when people have left. Those that have time. Okay, so you can see it's Windows 7 Ultimate. You can see the data was installed. You can see the version. Where's this? There we go. This is the current build. So that's quite useful. Okay, so that's good. So, and the nice thing about this, you can also analyze the registry files in a tool called FTK Registry View. And I do have it on here. I don't think I've extracted any files though. But you can also use that to also check these values. Essentially what you're seeing here is exactly what you'd see on your own machine if you ran regedit. And you went through the hierarchy for your software version, applications installed and stuff like that. You're just doing it on somebody else's machine without altering the information. Okay, so that's useful. So then we can go to okay, so this is the SAM file. It's for the Windows system. And let's just grab which again. take a while. Okay, so here we're checking the SAM file from the registry, and we can see all the users that were created, which is Mr. Informant. We can see this. You can see that additional user accounts were also created, and then we can also see the login counts for the different users. And failed login counts is here. Failed login count. Okay, so, and this is how you build up your evidence. So you would see, it's important to know which users were created, what the SIDs are for those users, so that you can prove that that file was created or accessed or copied by that user. If it's a network machine that lots of people log onto, I mean, you need to prove that whoever was sitting behind the keyboard that you suspect was the person who actually did the crime. Okay, so that's some interesting stuff. And then, okay, so I mean, your registry contains a whole host of useful information. Okay, so let's just check what this file is. Is this interesting? I'm just going through stuff. I mean, I'm not actually following any process. It's just, I'm not really doing an analysis. I'm just going through what your type of information is actually retained in your registry and what you can actually gather from an image. So this again, we can see, you need to make sure you're looking at the right stuff. Okay, so this is informant. The shell bag is quite very useful. Okay, all of this stuff. But anyways, okay, so you can see the different folders that's been used, and all the information, modified date, access date. Okay, that's pretty cool. And if we wanted to go look at what people have been browsing, what they've been typing into their search engine, we can come here. Browsers, and then it pulls out the different information. So here's Windows. These are this is my Internet Explorer, the file, the URLs that were accessed, sites. This is Google.
Is that FPI like on the cache?
Yeah, it's in your app data. There's various places. It does tell you at the bottom here where it's actually located. So this is where you'd find it. See, user informant. This is the guy that was suspected of copying the stuff. So we can see here, there are various ways you can see this, right? So these are the sites that were accessed. And then you can look at search terms, and this is where you actually build up your timeline. So I just want to. Because I'm not looking at the timestamp at the moment. I'm just showing you what was typed in, so that you can get an idea. So search terms were leaking confidential information, Internet Explorer 11, information leakage crimes cases. Leakage cases, Google Drive, data leakage methods, Apple iCloud, Nother. There's also okay. And then you've got a few different browsers. You've got it for Internet Explorer. You've got it for Google Chrome.
Just a question.
Sure.
I believe there's a process that you need to follow to do a proper investigation on all of this. But can this Microsoft tool walk you through that process?
There is a timeline right at the top. So you need to, obviously when you're linking the drives and all that stuff, you need to get all the information. So you're linking the flash drive that was put in on the network, the timestamp they were accessed, So you need to go through it's actually you walk through a timeline. So you put the evidence in a timeline. Not to say you're going to find all the evidence in that specific order. It's just when you write your report, you're going to say, okay, well, they first stole the files, then he went to go look at file sharing, and then he went to look at external drives and forensics, anti-forensic tools. So I mean, this guy's clearly showing intent. He's trying to hide what he's doing. It's obviously enough for you to judge. You just put that in your report. And it's actually for the defendant to go and explain why he's searching for anti-forensics tools. Yo.
Like, maybe it's a stupid question, but like, let's say you open up Chrome or Firefox, incognito window. It's not going to leave that much behind, but does it leave nothing behind?
I've never checked it, but I mean, there's still latent stuff left behind, right? I'm not sure what incognito would do to form values and stuff, because the search terms and when you're filling in forms and form values, all that stuff gets locked.
Session cookies will be kept until you close it.
The point is they never write this. Or at least Firefox private messages.
What happens if you combine that clearing that?
Well, if you're doing a live
if you're doing a live image, you would capture these.
You might get stuck in memory because it's, unless, I don't know, how careful they are.
Oh, you've got to see it eventually, so it's got to be decrypted.
Yeah, but once you're finished with it, they can clear memory locations. That's otherwise, if you say the memory dump, then, I mean, if you do look at memory dumps, it's amazing what you can
Maybe it's swapped out to distance of the page file, it might be there.
I think this could be.
In terms of that, you'd probably, if your company has a proxy or a VPN, you'd probably catch that. Look at the logs, match the logs up to times that you launched the
Yeah, if you're going through a proxy, you can see everything.
Exactly.
I think there is a header for privacy mode as well, but sometimes they seem to say that. So.
Okay, so I mean, you basically what you would have in a Windows system, you'd be able to analyze here, such as your system event logs. You could.
With the filter, you obviously filter times, but can you filter more? Like
yeah, you can.
Filter out the average things that Microsoft has by default, so you don't keep staring at everything all the time.
You can. I mean, you can search. You can create your own filters and stuff. Like for the system event logs, it's going to show you everything by default. But, I mean, you can filter this out just to go look at your system startup, and then that's all the events it's going to show you. Okay, and you can also just look for specific users using the SID, source name, computer name, and type. Okay, so now you can actually go build up a timeline when the system was actually operational. Okay, so if something was done, it doesn't not just say it was done from this machine. So you need to, if it was done from this machine, you need to be able to prove it was done from this machine. If this machine was off and files were taken off at a specific time of the network, it's not going to be here. Okay, okay, cool. So, well, so there's loads of stuff in the registry. So I just want to get some more. Like your DHCP, your IP addresses, which is also pulled there. Okay, so those are your network cards, your network profiles.
What is it, shellback, section?
Oh yeah. Well, there's various ones.
Most recently used items.
Yeah. Yeah, that's exactly it. Okay. Cool. Okay, so yeah, you can see your mounted devices, which are your floppy drives. So I need to get the right one, of course. Okay, so it's Windows, that's the wrong one. So here's your TCP IP configuration. You can see your DHCP address when it was obtained, when it terminates, and on which interface it's on. So you can trace it back. Users can't go and, obviously if you're using a registry cleaning tool, you can go and try and clean up the stuff. But some information is stored in more than one place, so it's possible you may find it.
And obviously you'd leave traces of the registry cleaner.
Yeah, there's actually there's some applications were downloaded to try and cover up what he was doing and cleaning up registry. CC Cleaner was downloaded. So, I mean, all of that stuff points that he knew exactly what he was doing. You don't download that stuff by accident. And all that stuff goes into your report. I mean, it's for the lawyers to show intent. I mean, you just say this happened at this time. This is the evidence. This is where it is on the disk. Okay, cool. Yeah, mounted devices. What is? Okay. Time zone, Eastern Standard Time. So I mean, you could get we get all the information from here. I just want to check. I just want to show you where you can see what network drives that were accessed and that. Just want to see where it is. Right. And then obviously, if you go through the whole case, they actually corresponded up via email. So then you'd actually look at the mails sent between them. Mails, and then this is the guy's email account, and then you've got also. I mean, you can view all this information is useful, because you can look at the hex view, you can look at the image information. So, okay, and then obviously from who to who, and it's the same for your social, like Skype and all that stuff. You'll see it will also pull your instant messages in. There was no account created on this image on the machine before the image was taken. So you'd have exactly the same thing. On the newer versions, you can also do a connection graph. So it will see if you've been chatting in a group, who the participants were. It also shows whether it's an incoming message or an outgoing message. And that's graphical, so it's easy to interpret. And it's easy for somebody who's not, picture paints 1,000 words, right? I mean, going through something like this might not be interesting to you, but but going through something like that, looking at emails, so that all this type of stuff is available, and then eventually, this was pretty cool, and I've never seen this before. Was that this was done? So they actually drew up a timeline graphically, and this is perfect. So you can see exactly what happened. This is obviously D-Day over here. It was when he was caught, and he was also trying to delete stuff. This was the day before, and that's the day before that. Okay, so it starts from when the machine was installed, and you can see where it was copying data, where it was copying to. So the report is not like this. The report is actually, you can put this in the report, but obviously the report contains all the information. And why it's relevant. Yeah, you're not going to put in your wife's recipe for pumpkin pie unless it's got arsenic in it, because it's relevant. Yeah.
What would the court do in the case that the person says no, but they didn't do it, somebody hacked them and pretended to do it on their behalf, like almost like a friend?
Yeah, but there would be, I mean, if you were hacked, there should be a record of it. Yeah, obviously, if there's a picture of you at a football game and it happened, your machine, then you can say you were hacked. But if you're at home and it happened on your home computer from your home network, it's going to be a tough one. You're going to need a good forensic investigator.
But it can also be a problem if you've got an office with lack security where everyone shares each other's machines.
Yeah.
Oh, for sure, but they should. But then it comes to your office policies. Each person should have their own username, and then you would tie whatever activity the activity should be tied to a username. So if you've got an open terminal, then there's absolutely no way to prove, unless there's a camera, and the camera's timestamp is synced to exactly the same NTP server as the computer. I mean, there's absolutely no way to say definitively that person was sitting behind there. computer at that time. Okay, so yeah, that's just some of the stuff you can. I know we basically rushed through it. There's a lot more stuff. I'm sorry that we rushed through it, but we're going over. If you've got a couple of minutes, we can maybe do a quick image of a flash drive. I know it's overshot quite a bit. What I can do is I can show you some imaging software while we got this thing up. It'll be quick, and then we can maybe just wrap up. Any questions while I'm busy doing this?
Do you have any recommendations on best free tools?
Yeah, well, a lot of the paper that's in the links in there is it's just to do with imaging, right? So all that stuff's free. So FTK is free. For forensic analysis, you can use something like SIFT Toolkit. That's free.
And
very
is
cool
it
tool.
highly regarded in the industry?
A lot of your private companies are using Windows-based stuff just because people are not familiar with Linux. It's like anything, you know. I mean, big corporates use Windows. That's their that's their default platform. So, and a lot of the forensic tools are only written for Windows. They're not written for Linux and Windows and Apple. As far as I know, there's no Apple forensic software. But these tools, all these forensic tools, can analyze apples and stuff. You can also analyze phones on Balkasoft. Access data, you can buy different modules. You can buy the known file filter, that would be a different server. You can buy the mobile phone examiner, that would be something else. Each thing has its own license. So, to give you an idea, virtual image, you're talking about virtual disks?
Yeah.
Yeah. Balkasoft analyzes that as well. I actually pulled in one of, sorry?
Containers then as well.
It should. I mean, you can pull in there. You can do a folder and file, so it can pull it. By the way, interpret correctly, it's not a different story. So yeah, this is Access Data. This is free from Access Data FTK Imager. You get a command line version, so you can do images of Macs. You can do images of Linux. So you do something. You just go, let's say, create a disk image, and then what type of disk image you want to do, whether it's a physical disk, if it's a flash drive, you do a physical disk, if it's a hard drive, do a physical disk, logical drive, image file, contents of a folder. So you'd select whatever you want. So you want to do a flash drive, you'd select what you want to do, which is one of the internal hard drives, and you'd say finish. And then you can add your image destination, which could be an internal hard drive, external hard drive, and then it's just, and then the type of format, okay, which is DD, RAW, expert witness, okay. And then you put your details in, case number. Now, if you've got 42 hard drives, you're going to have a system. How do you identify which piece of evidence? It's exactly the same as any other type of evidence being collected at a crime scene. Each one's going to have a number. It's going to be sequential. It's going to maybe have the initials. Whatever your policy is that you're using in your lab, you use this here. It just makes it easier. And then when you write your report, you can you know exactly what you're writing down. It's not, okay, this time I used 4 digits. Next, for this image, that image, I used 7 digits. You can have some standard. Okay, so then you just do that. Cool. Okay, now also bang for buck Raptor software. This is the best. It's your poor man's write blocker, because it boots up of a flash drive, and whatever you stick into it's only read only. So you can, you'll stick the source in, that's read only. If you attach an external drive, then that would be read write, and then you'd create the image from your source to your destination. It runs off Linux. Sorry, just want to get that quickly. I'll just show you what it looks like. I apologize for running out of time. Oh, shit. Okay, so when this comes up. Okay, so this is FTK. This is Raptor. So as I say, it boots up off a flash drive. And then it's also similar to FTK Imager. You would select the source, and then you'd select your destination. Okay, so you'd select your source, and this thing allows you to. Okay, it's clearly gone to sleep, like all of you. Okay, so it's gone to sleep, but anyways, yeah, you create it, so it's essentially a write blocker. So quickly, why you need a write blocker? You don't want to be changing the evidence one bit, so that's why you're gonna boot up on something like this, make an image, make a dead image. You don't want to be changing any files on the file system, on the disk, logical or physical. So yeah, you'd use a write blocker. You get hardware write blockers that you plug everything in. You get software write blockers like a USB soft blocker that actually goes and toggles the switch in your registry to not allow that disk to be written to. You get free ones, you get ones you pay for. I downloaded a free one today, which I was going to use. But, yeah, so you get some free stuff. A lot of the open source stuff is free. There's a lot more tools becoming available, as I've found it in the last couple of weeks. A lot of Python code that's available to do forensic analysis, to do file carving. You can use native Linux to do file carving. So yeah, there's a lot of information out there. But yeah, there's no reason not to go open source. But if you're corporate, then it makes sense to get like big servers that can crunch and analyze the data and give you nice pretty reports and stuff. If you obviously just have to, it's like anything, you need to be able to justify the costs for the licensing fees and the hardware and stuff. So yeah, that's basically it. There's nothing, I apologize for overrunning. Hopefully it was interesting enough for you to sit here. I hope it's not just the free beer you have for. So yeah, so and I would like to have shown you a bit more, but all the information is in the slides. If you have any questions, please ask. Yeah, so let's just... Are there any questions? Okay, so let's just get back here. Okay, so yeah, so that's I thought this was pretty cool. You can follow, it's quite easy to follow.
So was that generated by someone at NIST based on that image?
Yeah, NIST they actually put that in their report. Okay, so yeah, so this is some good guidelines. I didn't put in. I'll go find some places. I mean, I'll put SANS in here, but here's an RFC, which is good guidelines for evidence collecting. The ACPO, obviously, these are very good. Yeah, so there's some good free stuff available from reputable institutions. I mean, this is very reputable. Okay, so yeah, any questions on this? Did you feel you learned something? Tell me if you didn't, it's fine. I know we rushed through a lot of this stuff. It was more theoretical. I was hoping to be more practical. But as long as you learned something or enjoyed it. Any other topics you guys maybe would like to have talks on?
Have you done the Android forensics?
I do have it. This tool actually does do it. I have played around with it. So I have done it, yes. But it's exactly the same. I mean, a mobile phone, a lot of your applications use SQLite, so the tool can actually analyze. A lot of forensic tools can do it. Nothing, I mean, I'm not plugging Balkasoft on my trial version, I was just playing around with it, so that's why I decided to use it. But I've never done any phone forensics on SIFT toolkit. I don't know if that's going to work. I don't see any reason why it won't. I mean, you're making an image of the thing. It might not tell you exactly this is an Android version or this is the soft firmware version. This is the type of device. It might not be able to read everything or interpret everything from the image. But I'm sure you'll be able to pull out the images and obviously your social media databases and stuff like that. You'll be able to read that. Yeah. So, okay.
If you're worried that the accused person, you're going to go and collect information or evidence, and you're worried that in court the accused person is going to try and say that no, you tampered with the evidence. How do you prove that you took your hashes before you made changes?
Well, you'd make the images in front. Well, you'd normally do it on the premises, and then you'd take your hashes immediately after that. You're just going to I mean, of course they can say that. If you go to someone's house in a civil case, they're going to be there. I mean, they're not going to say, I'm going to Nando's now. They're not going to be happy that you're there. So they're going to sit and watch you.
But still, so you run your
do it on
image.
video, for example.
The thing is, you're going to take your hash at a specific time.
Video, one way.
Yeah. That kind of answers my question. Because if I'm walking into your house, I take an image, I run a hash algorithm on it, I walk away. Afterwards you say, well, how do I know that's the same hash that the guy collected when he made the image?
That's fine. If you shut down, if you say you do dead forensic, if you do a dead image, if you shut down the machine, say it's 7 p.m. and you start making your image, there's not going to be any file on that file system that's altered after 7 p.m. If you boot up that image, if they can prove that there's a file at 9 p.m., then they've actually got a case.
Yeah, you see, no, I don't think you're answering the question, because I think Liam's answer is more, you need something which is
you need proof external to the thing.
But you need to look at what's practical. If you've got 40 machines that you're imaging, you're going to start imaging them all at exactly the same time, or you're going to try to do multiple images. So you're not going to have, if you do 10 machines at the same time, you're not going to have 10 video machines.
You will need it, because
I disagree. The thing is, you're gonna be. It's not for you to. You're gonna have your hashes. So if I take an image of a machine now, the last file is going to be before now. So if you say that I altered, that it's altered,
you can go and edit the file system table and put the file dates back to where you want them to be.
And then the hash changes.
No, but then you're gonna, after you have fixed your evidence, you'll go and make a new hash. The question is, how do you prove that the hash was taken before changes were made?
How do you prove that the forensics guy wasn't a fraud? Isn't fabricating evidence?
There's no way to prove that, but the thing is, you're going to be taking your hash. If you change anything on that thing, you're going to change that file system. The hash is not going to be the same.
Okay,
you can fix that.
Let me present a scenario quickly. Let's say you're a forensic analyst and you're going to take some, you're going to create hashes from some image that you've made. Now let's say you fabricate evidence on this machine or on this image, right? Then take your hash, and in the meantime, the person that you grab this image from, oh wait, the stuff is seized, isn't it, right? Or
seized, yes.
Okay, so in that case,
you can't just go get evidence.
Any evidence that you collect, the police grade you, and there's going to be multiple people there. You take the computer, but many people there at once say, okay, we're going to take an image of this, people watching,
that's
to follow.
So now you're saying witnesses.
Yeah,
they're not going to be the same ones doing the analysis necessarily. So that's a trustworthy person, competent person, seizing the evidence, and that's what they do as a job. It's not.
So at some level, it comes down to trust.
Well, not only that, in a civil case, you're going to have the sheriff of the court there. You can't just go to somebody's house, I'm managing your computer. You're going to have the sheriff of the court. Someone has to serve
that. There's always a witness.
There should be.
There should be.
Okay. Go ahead. We're going to agree to disagree on that. Yours is a solution, but if you've got multiple machines, it's not a solution. I don't know if you agree with that.
After each one, if there's competent people around, you just give the guy a copy of the hash you've taken, and then it's not like you can't take it.
I'm saying the investigating officer is there, or the sheriff of the court is there. Get him to witness it, sign it, seal it. It's like there are ways to do it, but it has to be external to the hash. I understand what he's saying. Otherwise, you take another hash later after you've fiddled with it and present that as the original hash. Unless somebody's verified the original hash, and can say, well, no, hang on, the hash number's changed. Then, the question could be there.
Good.
But, yeah.
Okay. Anything else? Any other questions?
No? Cool.
Allegations, anything? Well, thanks very much.
Thank you.